Okay, we're back. This is for AP Physics 1. We're going to do a quick video here that talks a little and answers this paragraph length response, get us a sense of what we're doing in this problem. In this case, it's got three figures immediately, and they're showing you, in the first case, unstretched, you have just spring by itself. Second case, you hang a mass from it, and it stretches to a length of L2. And in the third case, you physically pull down with your hand, and it's got a stretch length of L3. As we look at that, they're going to ask some questions, and so we're going to answer that. So you should have read through it, and it tells you a little bit about the fact that L2 is going to be greater than L1 when you hang a mass, and L3, you pull it down even more, it should be greater than L2. So we're going to do this on the dot below, which represents the figure, the block, draw and label the forces, no components exerted on the block. Each force must be represented by a distinct arrow starting on, pointing away from the dot. So let's take a look here at, move this to the next page. So we just look at the free body diagram of that situation. You're probably going to have a force due to gravity acting on that object. The person pulling, so that's the external force from the person, and then the force of the spring. I'm not sure exactly what the pulling force is compared to the force due to gravity, but I do know that since it's in equilibrium before we let it go, then the two forces downward have to balance the force upward. So the arrows for the two downward have to somehow be similar to if you added the length of the two vectors for the other two. Hope that is something what you considered. Okay. Then it says in a paragraph length response, they're talking about three different parts of the system. And they say system 1 is just the block, system 2 is the block and the spring, and system 3 would be the block, the spring, and the earth all together. And they want you to talk a little bit about what happens to the total mechanical energy of each one of those systems, the block and the spring, and the block, spring, and the earth. And in the case of you released it and it's on its way upward before it gets to its equilibrium position. Okay, so I think if we go on to the next page, we can talk a little bit about it. If you look at system 1, which is the block, as it moves, I think it's going to have kinetic energy. That's going to be your 1/2 mv squared kind of thing. And as a result of that, as you let it go, I think that part of the system, if you look at that by itself, that should be increasing. I think everybody sees that as you let go, it's going to pick up speed as it goes back to that equilibrium point. Question might be, would it be if you had the block and the spring? In that case, that's going to have the kinetic energy of the system plus maybe the energy in the spring. And in that case, you have a 1/2 mv squared and a 1/2 kx squared, which would be the potential energy in the spring. Let's come back to of whether or not we think it's increasing or decreasing in just a little bit. If you go back and you say, okay, the third has the whole system. In that case, I think you should have the kinetic energy of the block, potential energy in the spring, and the potential energy due to gravity. We look at that. And so we move that up a little bit and we take a look at that, but that's a closed system. So that should equal a constant. So I'm going to say for the last part, the total energy of that system does not change. The potential energy due to gravity is a changing thing as it moves up. You've got an mg delta h, that sort of situation. So it's gaining potential energy in the system due to gravity. That part of it is going to take away from the other part of the potential energy due to the spring. So I think makes sense to me that maybe we take a look at these three different systems and say, in this case, this is going to have to be the, if I change that to another color, the block and the spring, this is going to be the total energy minus the potential energy, because we don't have any potential energy in it. So as a result, I think with the block and the spring, we're going to have to say that that part of the system has decreasing energy. Okay. So if we go back up, we take a look, it's interesting. It's interested in asking the question is, indicate why the total mechanical energy is increasing, decreasing, or constant for each of the systems. We again said for the case of the block, it's increasing. We said it was decreasing for the block and the spring. And we said it was constant for the block, the spring, and the earth. There are many questions where they talk about these systems. So you really have to take a look at each piece separately and go from there. Okay? So as the thing comes up, I think the block has to gain, whereas the block and the spring are going to lose, but the whole system stays the same. Okay? So that's what I think the answers to those questions are. Pretty straightforward situation. There wasn't a lot to it, and I hope this was useful. Okay? I think that's it for now. Have a good one. Stay safe.